Section 6.4 is on inverse functions. First of all, we have a definition of inverse relations. It's when the outputs exchange with the inputs. So if I'm going to take an equation like this one that they gave me, basically what we're doing is we're switching the x's and the y's. Okay? But usually when we write our equation, we want to have y by itself. So now I'm going to subtract 2 from both sides. X minus 2 equals 4y. Now we divide everything by 4, which leaves us with, here we'd have 1/4 x minus 2/4 is a half equals y. That would be the inverse of the equation that we started with. Same thing over here. Switch the x and the y around. Solve for y, so I'm going to subtract 1. X minus 1 equals negative 3y. Now we divide everything by negative 3. So here that's going to leave us with negative 1/3 x. Two negatives make a positive 1/3 equals y. And again, there is my inverse of the equation we started with. We are going to prove that two functions are inverses of each other. And the way that we prove that is we do the composition two different ways. You have to do both ways to do the proof. Notice that when you do f of g of x, it has to equal x. When you do g of f of x, that also has to equal x. And notice when you write f to the negative 1, that is read as the inverse of f, or f inverse. If I want to verify that these two functions are inverses of each other, okay, this is f, this is the inverse of f. What I need to do to start out with is take f of the inverse of f. Okay, now the cool thing is you're always going to know that your answer is x. If you go back here, your answer is always going to be x. You're doing the proof that it's x, so you do have to go through all of the steps. So now if I go through this, this is just like when we did compositions before. The first thing I'm going to do is plug this into the inside. So it'd be 1/4 x minus 1/2. Okay. Now we need to go to f of x. We're going to take this and plug it in for this x. So I'm going to bring down the 4. We take out the x. We put 1/4 x minus 1/2 in its place, and then bring down the plus 2. So again, it's 4x plus 2. Now we do the math. You need to show these steps. That's part of the proof. So I'm going to distribute. 4 times 1/4 would be 1x. 4 times negative 1/2 would be minus 2, and then plus 2. Now when we do the last part of the math, minus 2 plus 2 cancels out. That leaves us with x, which is exactly what we wanted to show this proof. Now we do have to do the other half of the proof. No matter what, you've got to do both. So now I'm going to take the inverse of f of x. Okay, so I'm going to write f to the negative 1 of, this time we plug 4x plus 2 into the inside, parentheses. Now I'm going to take this and I'm going to plug it in for this x. So we bring down the 1/4, take out the x, put 4x plus 2 in its place, and then bring down the minus 1/2. Okay, so just like we had here, it's 1/4 times our new x minus 1/2. Now again, show the steps. Distributive property, that's going to give us 1x plus 1/4 times 2 is 1/2. 2/4 is 1/2. Bring down the minus 1/2, and again, now those two cancel out each other, and you get x for an answer. And like I said before, you will always get x for both answers, okay? Notice it says to verify that they are. that means that they are inverses. You're doing the proof that they're inverses. Now we're going to find the inverse of some functions that have exponents on the variable. Now if you remember, f of x is the same thing as y. So what we're going to do is we're going to change this to x, and then we're going to write 3y to the 5th minus 2. Now we're going to add 2 to both sides. So I'm going to have x plus 2 equals 3y to the 5th. Now we divide both sides by 3. And because we've got these y to the 5th, we're going to write this as x plus 2 over 3 instead of dividing everything by 3, just to make this a little bit more simple. So now I have x plus 2 over 3. Now to get y by itself, we have to take the 5th root of both sides. Okay? And that leaves us with the 5th root of x plus 2 over 3. And that equals y. Now, I will say, typically, this is not a rationalized denominator, but for finding inverses, we're going to go ahead and just leave that for now. So we'll just leave the 5th root of 3 in the denominator. We're going to change this to an x equals negative 10 y to the 6th. Now we're going to divide both sides by negative 10. That leaves us with x over negative 10 equals y to the 6th. And again, we need to take the 6th root of both sides in order to get the y by itself. And that leaves us with the 6th root of, and I'm going to write this as negative x over 10 equals y. Okay? And again, that denominator is not rationalized, but for inverses we're going to leave it just like it is. So there is your assignment, and that concludes section 6.4.